Alright, let's go ahead and get into our 6th episode of our set implementation in Haskell. I know this video has been a long time coming, so let's jump right into it. What I want to focus on this time is making some tests for our project. We've got a very rudimentary project going on here, and we haven't really done much testing. So I'm going to start by making a directory called test, and in that directory I'm going to make a file called main.hs. And we'll go ahead and make a module for main. This will be our main test suite. And I'm going to use test framework, which is a Haskell package. Let me see if I can just grep it out here. So I've installed the Haskell packages or package packages test framework and test framework HUnit, which we will also use. So we'll import that as well, providers.hunit. And then I'm also going to import our sed module so that we can test it. And we're going to be working a lot with the text data type, so I'll go ahead and import that as well. And let's just start by making a main function. So test framework comes with a function called default main that will run a set of tests. So we could do something like test, and then we could do test case example, and do 1 is equal to 1. Right, something like that, I think. Like this. Okay. No errors there, so that looks good. And then I can try running this. First I need to get into this directory. ghc test main. Could not find, actually I need to install this one, test framework HUnit. Oh no I don't, I misspelled it here. There we go. ghc test main, and this operator is not in scope. We actually have to import this from HUnit itself. So I'll do that too. And I misspelled that. And now we have our passing test. So yes, indeed, 1 equals 1. So that's the basic format the default main uses. So what I want to do is create a bunch of different test cases. And I want to be able to compare our program's output to the original GNU sed's output. So one way I can do that, let's make a new function that is kind of like test case, but does that in that it compares our output to the GNU sed's output. So it'll take some command and some kind of text to run that command on, and then we should get back a test type, because that's what this function produces. We need a list of tests. So let's do that. And so this will be the text we want to run it on and the commands. And then we want to figure out what the actual GNU sed does, like what the output of it is from these two things. So we can do a read process of sed and then feed it our commands and our text. And to do this, we'll have to import system.process. So let's go ahead and do that. And then we want to return a test type, which we don't have yet. So we need to compare our sed program to the GNU sed. So we can do a test case, and now we need to provide a string, like in this case it was example, and let's just use the commands themselves as the string so that we can tell what the command was. And then we need one of these operators to compare ours with the actual GNU sed. So we can use our program, which it takes a Boolean value for quiet or not, so we'll just feed that true or not, true right now, and we can add that in a second. And then the commands we want to run, and then ours takes a data.text, so we'll just convert the text into a data.text. And then we can compare this with the output of GNU sed as a data.text, because ours is going to give back a data.text as well. So it should work like that. However, because we're using read process here, GNU sed is actually not a string, it's an IO string. So this whole thing will have to be wrapped in IO. So we can just make this an IO test and say return all of this to wrap it in IO. And to get out of that IO, we can just make this a do block and say tests, and let's see, here we'll get a sed case, or let's do test, we'll do sed case and give it some text like test this out, and then some commands. Like for now we'll just do p, and that should give us back a test that we can run with our default main. And this is not working. So it's saying ambiguous occurrence test. Let's get rid of this here and just open this up over here to make it easier to read. Okay, so it looks like test is imported by both test framework and hunit, so we need to hide it from hunit. And now we are getting a problem with read process. It actually takes an array of parameters instead of just a string, so we can wrap this like that. And now we've got our output. So the problem here, the reason it's failing is because I put a true here, and by default there is no -n flag. So now if we change that to false, then we get our working test. So that was pretty cool. Easy way to compare a test. Now what I'd like to be able to do is compare these in mass. So I'd like to have maybe like a bunch of tests that we can just make an array of strings, and then we can have here like p. We could even put this over here, p, and then like pp and np, something like that. And close it off. And then we'll want to use this we want to use sed case on all of these strings with our default text. Let's just make this test this out the default text for everything. So we'll just define this as a string. The text is going to be test this out. So now we can get rid of this stuff. And instead of just a singular test, now we want to get several tests out of this. So we'll just call it T for now, since we can't call it tests because that's already defined up here. And then we can use like a map m to run setCase. We need the map m because setCase returns IO. So we can do setCase, and we'll just use we use the text like this, and then the tests. Right? And that should work. And it does work, but we're having an error with our program. So our tests have already shown us something that's wrong with our program that we need to fix. And what I think we're going to find, I have looked over the code a little bit, and I think we're going to find that there's actually quite a few problems with our program. Just to edit this anyway. So right now it's saying non-exhaustive patterns. Let's open this up in here. In our next command. So I think what's going on here is once we get to the end of our text, we execute the next command, and then we are beyond the end of the text, and we're trying to print beyond the end of the text. So we need some way to catch it at the end within our next command, some way to catch it that will tell us we're at the end. We can't use any more commands after the next command. And this is going to be, I think, a recurring theme in our program, is that we need some way to say this particular command is the last one. For instance, in our delete command, what delete does more than just emptying the pattern space is really it says don't execute any more commands after this one. So this will also need some way to say don't run any other commands after this one. So one way that I could suggest doing this is by adding a boolean to our set state called skip, and we can just turn this on when there's a particular command that needs to skip the rest of them, and then we can turn it off at the end of each set of commands. So for now we'll put this as false here in our default state, and then our delete command should really just set this to true. So we'll just delete all of this and say it just sets skip to true. And then we also need a way here, we can make this a do block instead of doing it this way. And here we'll just change it back and say now we want skip to be false. Then in our next command here, we'll need to check to see if it's the end of the file. Actually, while we're here, another thing to think about is when we execute the next command, it needs to print right then and not wait till the end of commands to print. So we should actually be printing right here within our next command. So let's go ahead and get the state here, and then we can just run the command print. And then here we need to check if it's the end of the file. So we're going to say if it's the end of the zipper, then if it's the end of the zipper, then we want to set skip equal to true. Otherwise, we want to do the normal thing that the next command does. And we'll need to change this SS to just S because we're using SS up here. So we will just change these to singular S. Actually, let's make that a pattern for all of these, just in case we do need to use the state at any point in these functions. It will help us a lot to not have to worry about SS versus S. So I'm just going to change all of these real quick. Okay, that should be good. Let's try running that. Oh, and now we have even more problems. So now the thing we have going on is we are printing with the next command, and then it's getting to the print command and printing it again. So, or it's coming here and running the next command again at the end of the command. So what we didn't do, we set this skip boolean, but we haven't done anything with it yet. So we need a way to say if skip is true, then don't execute any of the commands. So just brainstorming here, one way we could do this is by making a run command take a command and return a state set state like it does. So basically the line underneath this. And we'll just say we only want to run the command if skip is set to false. So we're going to get skip, and it's going to be here sk, and unless maybe skp is better, I don't know. Unless skip, then we want to execute the command C. So now we'll change all of these. Instead of run command, we can call it execute command. Like that. And so now up here, when we run run command, it'll check to see if the program should, that particular command should be run. So here when we're printing, it won't get printed. So let's try that here. And we're still having some problems. Let's take a look here. We're still getting duplicates with printing. And let me think about why that is. Let's try just commenting this out, because now we have the next command printing. We shouldn't need this to print by default, since the next command is run on every line. So, okay, well now we're getting one passing, so that's better. The only problem is that we're not getting one extra printing at the end of all the commands. So at the very end, say we run the next command, it prints and then modifies one last time, we need that to be printed as well. So what we can actually do is change this to a do block, and then we can move that line we commented out down here. But I feel like I've done something wrong here. Let me think. That didn't quite fix our problem, did it? I think our problem is that we need to get the state one last time after we run this print command so that it updates it. Yep, that was the problem. So now you can see all our tests are passing, and we have fixed this bug by making some tests. So that was really cool. Now let's go back to our test file that we're creating. And right now we're assuming the -in flag is not present for all commands, but we want it to test for both when there is and when there is not a -in flag. So let's add a boolean here to our sed case that will be for whether or not the in flag is active, and then we can change this right here. However, we want it to match our GNU sed, so the GNU sed also has to have a -in flag here when in is true. So we'll just say that if in is true, then we want it to say -in and our commands. Otherwise, we just want it to say our commands, and then we can put that in right here. So now it should, if fed false here, it will make a bunch of tests with false on. So we'll call that loud. And if it's true, then it will make a bunch of tests with the -in flag on. So we'll call that quiet. And we can actually put these into test groups. This is a function from the test framework package that lets us just label a bunch of tests. So we'll say test group loud, and we'll call that just regular old sed, and then we'll do test group sed-in is the quiet group, like that. So then if we run that, you can see it's grouped these commands under sed. So these are without the -in flag, and they're all working. And these are with the -in flag, and they are not working. And I suspect part of the reason for this is because when we made these changes to the next command, right here we're just executing print without checking whether the -in flag is on or not, which is not how -in is supposed to work. -in means that next does not print. However, we can't get to this Boolean value from run commands from our next command. So we need to access that Boolean down here, but there's no way to get to it. So one way we can get to it is by pushing that also into the state. Unfortunately, we keep having to add more things to our state. So let's do false. Actually, let's not do false. This should be in, which is passed in to our sed function here. And then we can get rid of the in here. And actually, to simplify things, we can just use our parse sed s right here and delete that. And get rid of this Boolean and get rid of that. And here, instead of unless in, we'll just use quiet ss. And let's see, where else do we need to? So here, get rid of that because run commands no longer takes a Boolean. And I think we may have actually deleted more code than we added, so that it's not necessarily always a good thing, but it certainly doesn't, it's not a bad thing either. And then here, we can just check if it's quiet, and if it's not, then execute print. And all our tests are passing. So that's great. Okay, let's add a few more tests. Like let's try p in, and that works. And let's try dp. Oh, that got really slow. I'm not really sure why that got so slow. Let's try this again. something about adding D is making it very, very slow. Perhaps it's a problem with our program here. Oh, you know what I think it is this command here should always run. We should always go to the next line, whether skip is on or not. So let's see if that makes a difference. Yeah, that was the problem. So that worked, but we still have a problem here. We're expecting to get nothing, but we're still printing things out. Why is that? I think it's because we're executing print here instead of using run command. So I had execute and run command swapped. This line should be execute and this line should be run command. So let's try that. And now we're getting all of our tests passing again. Great, so the tests are helping us out quite a bit and we're making some good progress to our program. Let's just hash this out a little bit more. Okay, that's working. And as you can see, this is going to become fairly repetitive of continuing to add more and more commands to this test list. Perhaps there's an easier way that we could just like automatically say, for example, we could make like a command string that has P, N, and D in it, and then our test would automatically generate all of these possible sequences to save us some time. So let's try that. So let's actually jump into GHCI for this. And I'll load our test main. And let's look at our commands. So that's the P and D. And let's do a replicate 3. And then we can do, or let's do map subsequences. Let's just do subsequences. So if we do subsequences on commands, then you can see it's producing empty string P, N, D, P, N, but it's not getting NP. So it's not flopping these. But for now, let's just work with this, and we can edit it later. Let's do, let's try to map intersperse. Oops. With a semicolon over the subsequences of command. So now it's separating them by semicolons, which is good. And these could actually be, could all be valid commands. Maybe if I did a replicate 3 here, and then I would have to do a map because it's becoming an array. Okay, we're getting confused. Okay, we got commands. Let's replicate that by 3. And then let's map subsequences to each of those. And then we can join all of them and remove any extraneous ones. No, this is not. I think this is what I wanted. I wanted the map in M command. because if I use map m, then I can get pn and np. So this is all of the possible sequences of np and d that I can use. And then to this, we can map intersperse over it, and we get all of the potential commands. So that may not have been completely self-explanatory, but basically replicate m will give us all of the possible combinations. And if we pair that with these functions, then we can filter out the ones we don't want. And if we use map intersperse, then we can make them all into the said syntax. So something like that. And then let's drop out of here and try running our tests again. Okay, so we are using some functions that we haven't imported yet. So let's try importing, I think replicate m is in control.monad, data list, and I think that should be good. I thought we just made this work, so I'm a little confused as to why it's not. Oh, we put this parenthesis in the wrong place. That's why. And now we get 80 passing tests. So now we've tested our program with all of these different combinations of commands. So that's about as complete as you can get for testing to make sure it's like in accordance with the I don't know, with the original implementation. So I think that's enough for this time. Let's cut it off there. This episode went a little long anyways, but I thought this would just be an interesting way to make some tests, and I thought I'd share. I hope you enjoyed it, and I'll try to put out another one soon. Hope you'll have a great week.